Okay, the purpose of this lesson is to review back over the 5 types very quickly and to talk about how do you look at simply a list of compounds, whether they be the names of compounds or the formulas of compounds. How do you determine which of the 5 categories does each compound fit into, and then we're going to name it or write the formula appropriately. Alright, so we're going to start with a list of formulas of various kinds. Okay, so here's just a whole list of compounds, and we have to decide how are we going to name each one of these. Now, when you have a list like this, there is kind of a certain, if you find them in a certain order, it'll make your life a lot simpler. Okay, so the order you should look for them is, first of all, look for the acids first. Look for the acids first. Okay. The acids will be H, that's your key. Okay, so you look down over these and all of these here and you say, aha, right here, H something, this is an acid. Okay, we'll come back and name them in just a minute. Okay, the next one is, look for the covalent compounds. No metals. Okay, so let's go down this one. Okay, well, this is sodium. Sodium is definitely a metal. Remember, the metals are left of the stair-step line. Here's copper. I know copper's a metal. Okay, potassium, that's also a metal. Strontium, that's a metal. Nitrogen. Now, nitrogen's a nonmetal, and oxygen is also a nonmetal. So right here, I have immediately identified this as a covalent compound. Okay, so far we have identified 2 of these. Okay, the next thing is to look for polyatomic ions. Okay, and those are any compound that has 3 or more different elements. Alright, so let's look at what we have left. Okay, this is Na and O, 2 elements. Cu and Cl, 2 elements. K and F, okay, that's 2. Strontium, nitrogen, oxygen. Okay, 3 elements, so this one has a polyatomic ion. Okay, let's go down here. Sodium and oxygen and hydrogen. Okay, that's 3. Also the polyatomic ion, Fe and Cl. Okay, well that's just 2. Alright, so we have 4 to go. Okay, next is transition metals. Okay. These are elements that are in the D block, or tin or lead, Sn or Pb, are going to be treated just like any other transition metal. Okay, let's look over here. Na. Well, Na is in column number 1, so that's not a transition metal. Cu. Cu is in the D block. That's a transition metal. K. K is in the alkali metals, column 1. That's not a transition metal. Fe. Yep, Fe's in the D block. Okay, so what does that leave us with? The simple ionic compound zone we've learned at the very beginning those should be everything else. Okay, but to check yourself, remember, simple ionic compounds have metals in columns 1 or 2. Alkali metals are alkali earth metals, or in column number 3, the boron family. Okay, so here we have sodium. Sodium is in the alkali metals. Potassium, also in the alkali metals. Okay, now that we know what everything is, let's go back and quickly review how we're going to name them. Okay, remember the simple ionic compounds. You're going to name the metal, and you're going to take the non-metal, and you're going to change the ending to IDE, and that's it. So this is sodium oxide. Our other one is potassium, K and F, so that's going to be potassium fluoride. Okay, transition metals. Remember, the special thing about the transition metals is they have a Roman numeral in between the name of the metal and the name of the non-metal. The Roman numeral represents the oxidation state of the transition metal. Okay, so we're going to go right here, and we're going to say copper and chlorine. We know that if we look chlorine up on the periodic table, chlorine has a -1 oxidation state. Okay, so that means there's 2 -1 chlorine ions. Well, those must be to balance out, so that means the copper has to be a +2 to balance out 2 -1s. So that means that this is copper, Roman numeral 2, chloride. Okay, remember, the Roman numeral 2 is the oxidation number, which we had to kind of do a little detective work to figure out. Okay, let's go to our next transition metal. Okay, Fe is iron. And chlorine again is -1. Now we have 3 chlorines, so we have 3 -1s, but only 1 iron. So that means that the iron had to be a +3 to balance out the 3 -1s. So the Roman numeral will be 3. Remember, this represents Fe plus 3 is iron Roman numeral 3, chloride. Okay, polyatomic ions. Okay. For polyatomic ions, we're going to look at the metal. Okay. If the metal is a transition metal, it still gets a Roman numeral, but strontium is an alkali earth metal, so it's not a Roman numeral. So we're just going to name it strontium. Okay, and then I'm going to go in the back of the periodic table and I'm going to see, aha, NO3 is called nitrate. Okay, here's another polyatomic ion. This is just Na is sodium. That means that this has to be the polyatomic ion, OH. On the back of your periodic table, you'll see the OH is called hydroxide. Okay, next one are covalent compounds. Remember the covalent compounds? We're simply going to turn these numbers into prefixes. This means there's a 2, N2, 2 nitrogens, so that's di-nitrogen. Okay, 5 O's. The prefix for 5 is penta. Okay, and this is going to be oxygen. It's going to become oxide. Okay. Pentaoxide. Okay, lastly are acids. And now the last thing I have to do is decide, is this acid a binary acid or a polyatomic ion acid? Well, there's only 2 elements, so I know it's binary. I know the special thing about the binary acids is they have to start with the prefix hydro. This is chlorine, and so this could become chloric acid. Okay, this is challenging. This is the hardest thing about nomenclature, is putting all 5 of the compounds together. Alright, now we're going to go the other way. We're going to look at some names, and we're going to decide how we're going to write the formulas. Okay, I'm going to write down the names of a bunch of different kinds of compounds here, and we're going to decide what are we going to write for the formulas. Strontium arsenide, Okay, so here is our list of compounds. We're going to do the same thing. We're going to go through them one and quickly pick out what type of compound is everything. Okay, first thing we should look for is the acids. Well, these are easy because it has the word acid. Okay, let's get that out of your hair. The next thing is you need to find the covalent compounds. You need to look for prefixes. Okay, now this looks a little confusing. You say, well, this is di, but this is called 8. Well, aren't they supposed to end in IDE? Yeah, that's got to be something different. So let's skip that one for now. Okay, this is disulfur monoiodide. Okay, so there's definitely lots of prefixes. That's a covalent compound. Okay, the next thing we need to look for is the polyatomic ions. Now, obviously, you're not going to be able to just look at it and see the different number of elements. This is where you have to flip your periodic table over. You look, okay, and look for the name of any polyatomic ion here. Okay, so we say, oh, hydroxides. Hydroxides on the back of your table. That's a polyatomic ion. Okay, here, oxalate. Oxalate. Anytime you see something that's like, wow, that's a weird, it doesn't look like any non-metal, it's probably one of the polyatomic ions. Get comfortable with those. Okay, dichromate. Aha, dichromate is on the back of the periodic table. This is another polyatomic ion. Okay, now we're going to look for the transition metals. These are easy to identify because there's Roman numerals. Alright, I think right here at the edge. That's a transition metal. Here's another Roman numeral. Transition. Okay, and the last group are the ones that pretty much everything else. That's the simple. Strontium. Strontium is in alkali earth metals, and lithium. Lithium is in the alkali metals. Okay, so now we're going to go through, and we're actually going to do the covalent compounds first. Because covalent compounds, we don't need oxidation numbers. We don't care about oxidation numbers. Everything else, we're going to need oxidation numbers for. Okay, so we're going to start right here. The covalent compound. Di is 2. Mono is 1. So that means it's S for sulfur 2. Iodine. Done. Okay, now what we have to do with everything else, say let's go to the simple ionic compounds next, because they're the easiest to do. Go to your periodic table, look up the oxidation number for strontium, that's positive 2, and this is arsenic, that will be negative 3. Now remember, I'm going to switch these. I did not switch the one covalent compounds because these are not oxidation numbers. These come directly off of the prefixes. These are oxidation numbers. I have to switch their order. So the SR gets the 3, and the AS will have the 2. Okay, let's do the next simple one. Okay, down here, lithium, positive 1 off the periodic table. Phosphoride, that's phosphorus, negative 3. Let's switch the order, so the Li for lithium will get the 3. And P, remember, we don't write 1s in oxidation. The oxidation numbers, the positive and negative ions, don't appear in the formula. Alright, let's do the transition metals next. Okay, remember this, you have to remember, this tells you that the oxidation number for vanadium is positive 4. Look up oxygen on the periodic table, it's negative 2. When I write these, it's going to be V2O4. Now you're going to have to, if you ever run across this, reduce it. Think of it like a fraction. 2 to 4 can be reduced to 1 to 2. So this is actually VO2. Okay, here's our other transition metal. Okay, the Roman numeral 2 means this is positive 2. Look up fluoride or fluorine on the periodic table. It's negative 1. So that's going to be PbF2. Okay, the 2 to 1 becomes 1 to 2. Alright, let's tackle these polyatomic ions now. Okay, you're going to look up the oxidation number of your metal. It's positive 1. If you look up dichromate In the back of your periodic table, you notice that dichromate has an oxidation number of -2. You're going to do the same thing. You're simply going to switch them. So the K will get the 2, and the dichromate is just Cr2O7, okay, and that the 1 would go here since it's invisible. Okay, next one, calcium oxalate. Calcium is +2. You look up oxalate in the back of your periodic table. It's called C2O4, but the whole thing still has a -2. These two are going to cancel each other out. So all you're going to do is just write 1 calcium and 1 oxalate. Okay, almost done. Calcium, again, +2. This is hydroxide, the polyatomic ion. It has a -1. Okay, so the calcium 2 is going to go onto the hydroxide, and the 1 is going to go on the calcium, so it's just CaOH. Now, since I need to put a number on the polyatomic ion, I have to put it in parentheses. And then there'll be a 2. Hydroxide is the one polyatomic ion students forget to put in parentheses before they switch the oxidation numbers. Don't forget that. If you didn't have the parentheses here and just put CaOH2 without any parentheses, that's incorrect, because then you would only have 2 hydrogens and 1 oxygen. You need 2 of these OH groups. Okay, last one is the acids. Now you have to remember that the acid part means H+1. Okay, you know that's going to be at the beginning. Okay, then you go here and you ask yourself, okay, is this the binary acid or the polyatomic acid? Okay, you look at the beginning, it doesn't say hydro. So this has to be a polyatomic ion. Well, which polyatomic ion? Okay, it has phosphorus in it. Look on the back of your periodic table and you'll see phosphoric is either going to be phosphate or phosphite. Those are your 2 choices. Okay, well, if you remember that ic is the most common ending for acids, just like ate is the most common ending for polyatomic ions. So this is actually phosphate, which is PO4 -3. Now you have to write these you have to write them in reverse order. The hydrogen has to come at the beginning. Okay, so the hydrogen is going to get the 3. It's going to be H3, and there's 1 PO4. PO4. Okay, you're done.